Hello, everyone. Very warm welcome to today's webinar session. Thank you for your interest in taking the time today to attend this session. We hope you will have an engaging and interesting session from what we have to share with you today. I already see a lot of familiar names in the attendees, people who have been a part of our training programs. It's Hitika, Joby. Yeah, so maybe more people will be joining in a bit, but we will get started right now. So I'm going to share my screen. Yes. As you already know, the topic for today's discussion, sharing session and learning is using OpenStudio simulation tool in practice. As a consultant, we use many simulation tools in practice, and very frequently we try and share what we've learned, but we thought, why don't we do it on a webinar platform and extend that benefit to more people whoever is interested. So that's why we're bringing in this webinar today. So here in the room you have myself, Deepa, and my colleague Robin here in the webinar today. So a little bit about myself, and then I'll pass it to Robin, and then we'll do a little bit of introduction of EDS, and then we'll jump into the OpenStudio simulations. So I am a green building consultant, an architect by education. I have more than 14 years of experience in green building consulting, high performance, building design assistance, policy work, outreach communications, and right now I lead the sustainability education vertical at EDS, that's Environmental Design Solutions. And joining me is Robin. He's a senior energy expert at EDS. He has a wealth of information using not one, but several energy simulation tools. So Robin, could you introduce yourself briefly?
Yeah, definitely. Thank you, Deepa. Hello, everyone. So myself, Robin, basically, I'm an energy modeler. I use a lot of energy simulation tools for the energy simulations of high performance building. Then I have used the simulation softwares for HVAC system selections, for green building certifications. So I have been an experience of around 8 years in this industry. Yeah, so that's all about me.
Yeah, thank you, Robin. So yes, so we will be interacting through the session with you. Right, so I mentioned that some of you are already familiar with EDS and the rest of you may not be. So very, very brief introduction about EDS. Of course, it's a little repetition for those who already know about us and have been with us for a while. So maybe just bear a little bit with us over there. Right, so EDS, Environmental Design Solutions, is a consulting firm. Now, consulting firm in sustainability. Sustainability is a very broad topic. We specifically focus on the built environment. This is a photo of our office in Delhi. You can stop by if you happen to be in Delhi or you live there. EDS was established in 2003. We are now a team of 65 plus professionals, including architects and engineers. And since then, we've completed more than 400 projects across diverse expertise and areas. A brief about our services. I mentioned we are a consulting firm. So consulting is very generic a term, and you can do many things when you are a consultant. So at EDS, we provide consulting services on the things that's listed here, starting with energy, high performance building design. Here we give inputs on buildings or projects that aim for net zero energy or net zero carbon or any other kind of high performance goals. And then in policy advisory, we work with government or bilateral agencies to advise them on code development, give technical inputs on a lot of code development or research and so on. One of the notable work we've done is the technical update to Energy Conservation Building Code of India, that's ECBC. So that's something one of our team does. Another team at EDS, they focus on existing building commissioning and audit. They also help with existing building certification as well. Building performance simulation, this is the focus today in our webinar. A team, Robin is part of the team. They have expertise in many simulation tools, including whole building energy modeling, daylight modeling, glare analysis, CFD, and so on. A lot of this simulation work that we do does feed into the high performance building design consulting, but often it is also a standalone work that we provide a service on. Technology service is a little interesting. We use our coding programming skills into sustainability. So it's like an intersection of coding and sustainability. For example, we've built the ECBC app, right, which is called Pocket ECBC, and you can refer to the code through the app. Similarly, we've built dashboards for many firms so they can actually review their real estate portfolio across different buildings, in their portfolio. And finally, capacity building and education, where we provide training programs for professionals, for students, and also for corporates tailored to their needs. So that's a snapshot of what we do as a firm. So now we come to today's session, that is OpenStudio simulation tool in practice. I mentioned that we have, as a team, expertise in many software tools. And often we get asked this question, which tool is better, X or Y? I want to do this. Can I do this in this X tool? Can you teach me the Y tool? So on and so forth. And so as a team, we juggle between many tools, and today our focus is on OpenStudio. So Robin here is going to share his experience of having used this tool in practice, and he'll talk about the things that he has discovered and the things that he uses in practice to build very complex models, and looking at it through a lens of simplifying it so that the process of simulation becomes more streamlined, especially when you work in a collaborative environment where many team members are working on the same model. So yes, so over to you, Robin, and please share your expertise with us.
Yeah, thank you, Deepa. So just give me I hope my screen is visible.
Yes.
Yeah. Okay. So hello everyone. So yeah, definitely I'll share my experience on working with OpenStudio by the help of a case study. So before discussing that, I just want to share my journey in the world of energy simulation, how I have started working in this field. So basically, I'm a mechanical engineer, and I have done my master's in thermal engineering. So during my master's, I just got an opportunity to select an elective course, which is energy simulation. So I think as many of you during your studies, when we see something new, we get to know about something new out of our coursework, we definitely got attracted for those things. So I think that was the obvious reason I got attracted for this course and then start learning. So I just got introduced with Lattice Screen, that is one of the software which is used for clean energy awareness, decision support, and capacity building tool. Then there is another tool that is PVSys, which is basically used to study the performance or sizing the solar PV systems. Then obviously the EQS, one of the energy simulation tool. which we generally use to evaluate the energy performance of the building. So at that point of time, I just get to know about the tool, not much in detail, but have a fair enough idea that what these tools are and why it is required, how we can use these tools. So after that, based on my performance.
Just 1 second, Robin.
Yeah.
There is some part of the slide is not visible. Could you exit from this presentation mode once and then start again?
Okay. Is it fine now? So I just put it in the read.
Yeah, I think the zoom controls are sort of overlaid on it. Is there some setting for that? No, right?
No, as such no.
Okay, you can go ahead.
Yeah. So yeah, so based on my experience during the course, my professor just gave me an exercise to do on the energy simulation software. Obviously, it was not the front-end exercise, it was the back-end exercise that I have to analyze the algorithm of Earth-air tunnel system in the Energy Plus simulation software. So basically, I have started working with the Energy Plus version 8.0. So I think if many of you are already working on that software or are familiar, the latest version of that tool is Energy Plus 9.6. So you can imagine that I've started in a very basic or earlier versions of the tool. So I just worked on the algorithm, then again got the chance to work on the front end of the tool. Basically, finally got the chance of doing some energy modeling. So you can see these two buildings. One is the actual image and one is the 3D image of that building. So this is my very first energy simulation model, which I've developed to analyze the performance of radiant cooling system along with cooling tower for different Indian climatic settings. So again, I have converted the same topic into my thesis of my master's course. And then on the same topic, ISRE has selected me for the REVA World Student Competition, which was held in Denmark along with the Klima 2016 conference. So I presented my work there and then got introduced with the many other energy modelers during the conference. And I think obviously just find out my interest in this field. And after this conference, I just got the opportunity to enter into this world of sustainability, or I can say the world of energy, building energy solution. So I have joined EDS in the year 2016 and started working with a very basic tool that is EQS for the energy simulation. So at the beginning, I started with the compliance modeling, then started doing design optimization in the EQS tool. But as soon as I have I work on these tools, later on, I saw that it is slightly difficult, not easy to model complex buildings in EQS or complex, or I can say advanced HVAC systems in the EQS tool. So I just move on to the Energy Plus because I have a prior experience on this tool. But again, modeling city geometry is not that much easy in SketchUp. So at that point of time, I struggled with that. So finally used design build software for the creation of geometry. Then import that model into the Energy Plus for further working. So that's how I have moved on from EQS to Energy Plus and Design Builder and start doing modeling more complex buildings, start analyzing more advanced HVAC systems like radiant cooling systems, geothermal systems, VRF systems, and so on. So once I got a fair enough idea how to deal with these tools, then just because of project requirement in the way back around in the year of 2018, I have started working on OpenStudio. So I think at that point of time, with my very first model, I feel a lot of difficulties how to model 3D geometry in OpenStudio, because we have to create the geometries in the SketchUp. And I'm from the engineering background, so not that familiar with the architectural things. But as I mentioned that I have an idea of backend of Energy Plus simulation software, and both these softwares, Design Builder and OpenStudio, basically they are just the GUIs, but the backend, or I can say the algorithm part or simulation engine of these softwares is the Energy Plus only. So it takes a very little time for me to get handy with these softwares. So I started working on OpenStudio, started doing complex modeling, started building complex building models, then used to do all type of energy modeling, whether it is a compliance modeling, design optimization, or HPC system optimization by the help of OpenStudio software. So till now, I have completed more than 30 compliance modeling projects. I have worked on more than 20 design optimization, or I can say HPC system optimization projects. So as you can see in our building energy solution industry, the typical approach of learning any solution software is to start with the front end, that is the GUI of the tool, and then based on the requirements, or I can say the project requirements, we started looking at the back end, that what is the algorithm that is going to be used for doing a particular analysis. Just take an example of load calculation for any building. So first we start working on the software, then we'll see that on which algorithm this software is working to calculate the cooling load of the building. Similarly for the daylighting or other type of analysis. I can say, I think most of the energy models follow the same, but with me, the approach is slightly different, that I have started from the back end. What is the algorithm that is going to be used for different components of a simulation software, or I can say for different HPC systems, and then got introduced with the front end, that is the GUI of the tools. I feel both the approach are fine, but when you are ready with your basics, it's quite easy to switch in between the simulation softwares, because you know the basics, that how the things works in the simulation softwares. So I just want to share my experience with the help of project which I have done in the areas. So I have worked on a building which is a part of a big campus that is around 27 acres. So this building, the built up area of this building is around 0.5 million square feet. And the basic objective is to optimize the energy performance, and then finally analyze or do the compliance feasibility as per the green building certification requirement. So before discussing the project, I just want to discuss this typical project cycle that many of you are already aware. I think that any of the building project starts from the design initiation, and then go into the concept design stage, then develop design stage. And once the design is finalized, then we have detailed design, and then construction and handover. If I think in terms of sustainability expert, in most of the project, the sustainability experts get into the project after the developed design stage, that is in the detailed design or construction stage in general. just for the sake of compliance modeling, or just to verify whether the design is okay in terms of energy efficiency point of view or sustainability point of view. But if sustainability consultant enters or involved at this stage, they will not add much value in the projects. So that's why according to me, they have to involve with the in the project from the initial design stage, so that they can provide their input, or they can give their input to the design team based on the sustainability point of view, and it is more useful. So in this project, we have been involved in the project since the initial design stage of the project. So we have worked along from the sustainability point of view. So I've created the model in the OpenStudio software, and these are the final, I can say, the parameters which has been finalized for the envelope of the building. But so you can see these numbers, but before finalizing these numbers, we have a lot of discussion with the architect, with the design team. So we have started with the brick wall, and then finally analyze the option of AEC block, then come to the concrete block, and then come to the insulation. So we have analyzed all the things in the OpenStudio software, that how the energy performance of the building will get changed upon changing the construction envelope of the building, of this building. So then we have worked on the internal loads of the building, just like lighting, power density. So we have started with the more basic numbers, that is 1 watt per square feet, which is generally the industry standard as per ASHRAE. So we have fine-tuned work along with other consultants, MEP consultant, lighting consultant, and optimize these numbers by the help of software. We have also did the cost analysis also, that if you reduce the lighting power of the fixture, how much additional cost you will be there, and then what is the improvement in the performance of your building, you will be able to get to know. Similarly, these are the parameters related with the equipment power of the building. So when I started modeling this building in the OpenStudio software, so I just want to, this is one of the very important or basic feature of the tool. I think every simulation software has this type of features, and every energy modeler knows about it, but it's very difficult. I can say they generally used to forget to use these features of the tools. So OpenStudio has this inheritance property, that you can define any parameter at different level, starting from the building level to the building story level, then space levels. So again, it depends at what stage of the project you are coming in. If you are entering or involving in the project at the later stage, you can, it's not quite necessary to follow the inheritance pattern, because it won't affect your energy modeling as much. But if you are involving into the project from the beginning, so because the life cycle of your energy model will be more, as you have started from the initial design stage, then you have to work on the same model during the concept design, then during the detailed design, and then for the compliance modeling also. So it is okay if you spend a little more time during the creating the model, so that while working at different stages, it will be quite easy. So just take an example. Let's say I have to define the lighting for my building. So I can define that lighting power at the building level. Then I have an option to define it at the space type level in the software. Then I can also define it as the space level. So whenever there is a change in that input, if I have defined that input at the building level, I have to make change only at the building level, and gets replicated automatically at other levels. But if I have defined the same input parameter at the space levels, so let's say if that building has a number of spaces as 500, so whenever there is a change in the input, I have to make changes at the 500 places in the simulation tool. So it happens quite of time whenever you are in a hurry to creating energy model, you just forget these things. But I think these are very important things which helps in reducing the overall energy modeling time. Initially, it seems that it will take or it will increase your energy modeling time, but finally you just get an idea that these things will obviously reduce your energy modeling time. So basically, this is a suggestion to the other energy modelers who generally used to work in the software. They just try to define the parameters at the high level inheritance. Then if it is required, then try to define it at the mid level. If by any means it is not feasible, then try to define it at the lowest level. So in the same manner, I have used the OpenStudio for this project. So I have defined the parameters at the building level, or I can say the higher level of the building, then middle level and the lower level, depends upon the complexity. So we have also worked on to optimize the HPC system of the project. So we have worked to reduce the load of the project, then what should be the energy parameters, what should be the efficiency of the chiller, what should be the pump powers for that particular project. So we come to these final parameters after doing a lot of iterations along with the MEP consultant. We have also worked on the air-cooled chiller for the same project. Then you can see the air side system. So we have a combination of DOAS plus air handling unit system. So with the help of this software, you can combine all these multiple systems and analyze in a one go. So these are the very specific features of these tools. So again, one more feature of OpenStudio that helps in modeling when you are involved in any project from the initial stage, that is the OpenStudio measure. So that measure basically make changes in your model without doing any manual modeling. So it's basically I can say a set of instruction. You just have to give an input, and it will make those changes related with the input to the complete model. So just look at these images. So on the left hand side, I have a building, and I have to add the shades to all the windows of that building. So there are two methods. One is you can manually add the shades to add to each of the window. So it will definitely take a lot of time. By the help of measure, you just have to provide a single input, and it will automatically add up the measures to all the windows of that building. So all these things which helps in reducing the modeling time. You can find the existing measures for OpenStudio on the building component library website, and these are basically helps in reducing the modeling time and cost, obviously, and maintain the quality and consistency in your energy models. So once we are ready with our inputs, we are ready with our energy model. We have analyzed the end results. So you can see the building is consuming around 47% energy in the HVAC and 38% energy in the equipment. And if you look at the EPI numbers, so it is around 92 for this building, and along with the integration of renewable, it is 80. So you can see that this is a very efficient building if you compare this building with the current standards. So that's how you can work in OpenStudio. You can use the features like inheritance features, major features, or you can very easily create complex geometries. So here's some other examples of some other projects where we have analyzed in and around thousands of zones in a building by the help of this software, and it's quite easy to handle these buildings in this simulation tool. So if you are if any one of you ever worked with the Energy Plus engine, so the output of Energy Plus is not that user friendly. You just got the numbers in the form of Excels or in the form of tables. So in EDS, we have developed few dashboards to analyze the output in the graphical manner or in more effective manner. So here's example of one of the dashboard, that is daylighting dashboard, which we have developed to see the ECVC compliance check by using the output files of OpenStudio software. Similarly, we have developed another dashboard to visualize the output, thermal comfort output, basically. So my approach to working with OpenStudio is very simple or very easy. The very first thing that you have to patiently study about the project, what is the objective of the project, what is the life of the project, whether you have involved in the project at the later stage, that is construction stage. So the only reason is to just verify the design of the project and then generally do the green building certification. But when you have involved into the project at the initial stage, just and will be able to give your inputs for the optimization of the parameters. So basically, you have to assess this purpose, and based on that, you have to develop a strategy and how to start with the model. Whether is it okay to spend more time at the beginning, or is it okay to spend time at different stages of the project? And with this OpenStudio software, try to define properties at the higher levels. So these are the basic features that you can use while working with the OpenStudio software. Yeah, that's it. I think from my end, I think you guys get an idea that how I use this software to work or to optimize the performance of the building. Over to you, Deepa.
Thank you so much, Robin. That was a lot of information that you shared with interesting case studies as well. In fact, you know, the tips that you share towards the end, I have worked very briefly with simulations, but it may sound like to the audience that, you know, study the project, it's like a pretty obvious thing to do. But maybe when you're starting, you don't really pay so much attention to the project, and your focus might be more on just getting the model correct, making sure every little tiny detail is in the model and so on. So I guess, Robin, when you started also, you might have kind of focus on the
Yeah,
model so
obviously.
much, right?
So I
And
think it comes when you start working over a period of time. So you get to know that what are things which makes your energy modeling make a little bit easier or make you comfortable, how to go with the models over a period of time.
right, I would say more streamlined and efficient in creating models, right? And that's how you could work on, 50 and 60 and hundreds of models.
Yeah, right.
While when we are starting, it just seems to be taking a lifetime to just get one model going when we are just starting and learning about it. So those are great tips. And yes, and if you have any questions for Robin, please send it in the chat. You don't have to wait till the very end of the session. You can ask as in when you like. If you want to know more about the examples, or if there is something very specific you want to ask about OpenStudio, if not that, any other tool also, feel free to send in your questions in the chat or the Q&A, either way. Even if you raise your hand, that's okay. You can speak. We'll unmute you if you wish to talk. Okay, so with that, I want to share my screen now. So all the expertise that Robin has shared with you, right? We have brought that into the OpenStudio series of training programs, and he is the instructor in all of these programs. OpenStudio, there is a little bit learning curve there, right? And as Robin mentioned, he started working with Energy Plus directly. And so it was easy for him to pick up either OpenStudio, Design Builder, any of these graphical user interface. So with OpenStudio or any energy modeling, it takes time to build expertise. As you work on more projects, you get comfortable with using the tool. The good part about OpenStudio is that it's open source. So if you are getting introduced to energy modeling, if you are building your skills on energy modeling, then it's a good tool to start with because it's available for free. And then once you develop sufficient expertise, you may then work with many other paid tools as well. Otherwise, of course, there's a myriad choices that you have in picking up energy modeling skill set. So here we have actually broken down the tool over 4 courses, which can be taken in a sequential way. So if you're very completely new to OpenStudio, then you can look at this as beginner to intermediate. If you are familiar with energy modeling, then it's more like and beginner to I would say intermediate to the advanced thing. So first part in our 4-part series is called Building Envelope Optimization in OpenStudio. In this course, we look at window wall optimization. So you run scenarios for different window wall ratio options, different glazing options, different wall insulation options, even orientation, building massing, shading, and pretty much all of this. So that's your first course. We talk about a process of running an optimization in this course. After that comes daylight and thermal comfort optimization. As the title says, it's about looking at daylight levels and thermal comfort. Now in OpenStudio, it is a little complex in how you actually run the simulation, and it's a topic in itself, right? So from our experience, we've come to formulate the program such that you get the best of every topic from each of these courses. There's no point in cramming everything under the sun in just a 2-week program. There are options for that also, but we don't tend to do it. So in the second course, you learn about not just daylight levels, but also compliance with benchmarks and energy code. Similarly, for thermal comfort, the ASHRAE standard and the code compliance as a benchmark to look at. Viewing results can be complex, but as Robin showed, there are some dashboards that we have made, which makes it very easy to simply import the results into it and view it for quick understanding of the results. The third and the fourth is focused on services, specifically HVAC systems. Third course is on the VRF system in OpenStudio, and then another one is on chilled water system in OpenStudio. What we are bringing in here is LEED version 4 compliance in OpenStudio for both of these systems. Why did we pick these systems? Because it's pretty, largely used in most buildings. So if you learn to model these 2 systems, I think you'll find a lot of applications in real world projects. So the first 2 courses looking at building design, and then the last is looking at system modeling. The focus is on that. Now we finished the course 1. So we are calling it OS 1, 2, 3, and 4. And so we finished course 1 in May, and we are beginning. We finished on 29th May. And then now we are beginning on Monday, the second course, which is daylight and thermal comfort optimization in OpenStudio. You can see here the topics that will be covered: daylight, and in that the metrics, the SDA, annual solar exposure, ASC, UDI, and then different controls. And for thermal comfort, look at these metrics. And then you have solar PV potential also in this module. So if you've taken OS 1 and then you take your OS 2, then you have covered the entire building design part, and you add the solar PV. So with that, you can actually, in a way, look at net zero potential for your project. And that's why we brought in the solar PV in the OS2. In case you're not interested to do with mechanical systems, then you can stop here and you can actually assess feasibility of net zero for your project. Of course, you look at energy performance, what is a trade-off between comfort and energy, right? And then various standards and benchmarks. So this program is starting on 13th June. And as Robin shared, he's going to actually share um, tips and tricks that he uses, and it's taken him few years to actually learn that and apply it in his projects. And that is something we're bringing into this program. So you will learn to check compliance for daylight requirements as per ECBC, to analyze comfort hours for naturally ventilated spaces. That's very important, right? Thermal comfort, if you have mechanical cooling, obviously it is going to be comfortable. But what if you don't have that? Then that's where the challenge of providing comfortable environment comes into play. So how do you really analyze that? Can you make a case for your design? You will learn to do that in this course. You will model daylight and glare control. You'll discuss trade-off between comfort and energy use. You look at how to use simulation outputs for design inputs. Maybe you're the designer, so you can take it back into your own design. Maybe you're part of the team who has to recommend this to another team member. You can do that by understanding the meaning of the simulation outputs. And we will share that through many examples. Our workshops are highly hands-on and application oriented. We design the assignments such that you are actually getting to apply all that you learn in the program into your project. Now, the early bird for this program has already closed. It ended yesterday, but we are happy to offer this to you right now because you've taken the time to attend the webinar. So we'll share the link in the chat for enrolling into this program. If you have any questions about it, please feel free to ask. And there's a barcode as well here. You can scan it as well. Robin, if you can just put the link in the chat for the OS2 payment link. And also,
Sure.
please add the link for our course website. So there is some more information on that. Meanwhile, I'd like to share, how the course is structured. It's a 2-week program, but you don't have to attend webinars for 2 whole weeks. So the webinars are scheduled in an evening, after typical work hours, like 6 to 8 p.m. Right, and which is comfortable for most working professionals and even full-time students. And the webinars will be scheduled on Tuesdays and Thursdays for 2 hours, and then the rest of the day you are given lessons to go through and assignments to work on. So you cover some ground through recorded video lesson, and then you learn the optimization part and the analytics part in the webinar, and then you have an assignment in that week. So overall it's about 10 to 12 hours sort of work in the week. So it's very comfortably spread through the week, right? And then you have the weekend as well to work on your assignments. And then the following week, you can see here the modules are divided as per the topic. Again, on a Tuesday, you will start with thermal comfort and then solar PV potential. So at the end of this program, you would have modeled your building. Here you have a choice. You can bring your own project, or you can use the sample model that we give you in the program to work on. And so you can apply the same process of daylighting analysis and thermal comfort analysis into your own model as well. So in the end, you will walk away with that 3D, having run a bunch of simulations and also looking at output and presenting it in a legible manner. Right. Other than these webinars, we also have classroom hours. This is optional to attend. Every Monday, we come in and just simply discuss the assignments and any queries anyone would have, even figure out some issues with the model in case there is any roadblock or some hand holding required. That is also offered on a Monday. So that's your 2-week capsule. Here is our website, and you can find all the course information. The link is there in the chat for you to for your handy reference. Now, I'll also like to mention here that very commonly our bundle programs, or say the course bundle is more popular than the single course registration. So I mentioned there are 4 courses in the series. The first 2 courses with the envelope optimization and the daylight and thermal comfort, we've called it the design bundle. And then the 2 courses on HVAC modeling is called the HVAC bundle. So maybe that is of interest to you. So we will look at lead compliance modeling in these courses. And of course, it's design and HVAC bundle if you want the full suite where you really get a good handle on using OpenStudio as a tool by the end of these 4 programs. So you may also enroll for these bundles. So there's a deeper discount when you take the bundle offering. Also, it gives you the advantage of a sequential learning. There's a good 3-week gap between 2 courses, so you have enough time to breathe and to really seek opportunities to bring in a project into your next program. Let me know if you have any questions. You can raise your hands. You can put your questions in the chat. And we can help you answer if it's to do with the program, if it's to do with the tool, or maybe the case study that Robin shared, either ways. Now, I mentioned that our first program, sorry, this is daylight. Okay, our first program, that is building envelope optimization, here, it's already completed, right? But you can still enroll for this and get access to all the content, including the recorded webinars, and take the whole course in a self-paced manner. We've had many participants who've done that. They've registered for the daylight course, and then they've also enrolled for the first one, and they're taking the content at their own pace. We always recommend that you take that, so you get started with OpenStudio from the very scratch to learn how to model the 3D geometry and so on. Now, in case you want to learn daylight, but you're new to OpenStudio, we still have the ground covered. We give you a lot of modules, which is about, let's say it'll take you about 2-3 hours of your time to catch up and bring you up to speed to using the tool. So there is already content that is available on our platform, and you can get started with just figuring out how to use OpenStudio right from there to getting you up to speed with running daylight simulation. So both courses are open to those who are just beginning to learn OpenStudio. So yes, please feel free to ask any questions if you have about the program. The link is already in the chat. The barcode is also here for your reference. So yeah, that is pretty much that which we had today to share with you. And we are here if you have any questions. Okay, there aren't any questions. So let me take this opportunity to share another thing that we have completed more than 18 cohort-based programs. This is our third offering of OpenStudio series. So over these years, we have like over the program, so many programs, we've actually arrived at a good, I would say, a program that is immersive, engaging, and really gives you the learning that you actually need over the course of 2 weeks. So what you walk away with is really solid learning of the tool. And that's coming from our experience of having used the tool in practice, and also observing other professionals struggle with learning the tool. Right, so we've brought in those nuances into the program so that when you are learning the tool, you're actually getting started on the right foot. Right, it gives you a good head start when you learn OpenStudio from practicing professionals. Right, so yes, so I hope to see you, some of you at least, in our classroom. Here is a barcode. Please make use of this opportunity to sign up for the program. This offer is only available for today until this webinar is there, like basically only for today. And you can see the link also in the chat. You can keep it handy with you, copied it in your browser. And yeah, if you have any questions, we can take them. Okay, so we don't see any questions. So I think then we can close the session for today. Thank you so much for attending the webinar, taking the time out. And we hope you found this useful. And we hope you will also get started or continue your journey in learning the OpenStudio Energy Simulation tool. Thank you very much and see you around. Thank you, Robin.
Yeah, thank you, Deepa. Thank you all.